Hello class, we will be working on single sums today. And for the first thing we're going to do is future value of single sums. In order to calculate the future value of these single sums, you need the future value, you need the principal value that you're putting in, plus the interest over the number of years you're having that investment in. So do any of you all have any questions or examples? All right, you young lady right over there.
Okay, so I really want to buy a car in 5 years, and I'm saving up in a big savings account. So if I put $10,000 in today at a 10% compound interest rate annually, how much will I have when I'm ready to buy a car?
Okay, so we'll start off first. You say you put 10%, so your 10% will be the present value or the principal that you're putting in there first. So we put that set that as 10%. Then your interest rate is the 10% interest rate, which is 0.010. That's the interest rate. And the number of years is 5, so out of 5 years. So then we will set up the problem, future value equals the principal plus 1 plus the interest over the number of years. And since your principal is $10,000 for that new car you're trying to get, plus 0.10 over 5 years, which is the interest and the number of years. And that equals 10,000 plus 1.611 times that will give you your future value. So your future value that you have saved up for that brand new car is 16,110.
Yes,
That is your future value.
a new Honda.
Woo.
Yes.
Any questions? Stop.
Today class is the present value of a single sum. Now, this involves computing the present value somewhere into the future at a given discount rate. You can see a present value equals the future value times the number of periods, and then you have that divided by 1 plus the interest rate times the number of periods, or raised to the number of periods. Does anybody have any questions? Yes.
I'm taking a trip to Paris in about 2 years.
Mm-hmm.
I wanted to have some spending money.
Mm-hmm.
How much would I have to put in the account today in order to have $1,000 in those 2 years? With
Well,
7% interest rate.
I love these problems. So we have our present value, like I said, which equals your $1,000 times the present value of a future thing times that 7% at 2 years. So from that we have this equals 1,000 times 0.873. So the answer to your question is you need to put $873 in an account today to equal $1,000 in 2 years. 2 years. There you go.
Thank you.
Yeah.
Okay, guys, we're going to work on the frequency of compounding. And with the frequency of compounding, most interest rates are done by compounding. Where N is the number of years, M is the compound period, I is the interest rate, M is the compound period, and P is the principal, and FV is the future value that you get. So, any questions? Okay. Questions?
I want to deposit $1,000 in my account, which pays 12% quarterly as the interest rate. How much will I have in 8 years if I don't make any withdrawals?
Okay. So, if you deposit that $1,000, which would be your principal, then to get your interest rate, you will need to have your interest rate and also have the number of times this period. Since it's quarterly, it would be 4 times a year, which would give you a 3% interest rate per quarter. Then you also need the number of years, and you put 8 years to this quarterly, it would be 4 again, which would give you 32 per quarter. Then you just plug it in the problem, is your future value equal to principal, which was $10,000, and 1 plus the interest rate, which is 0.03 over 32 years, which would equal 10,000 over 32, which will equal 2,575.10. There it is.
Shoot the question.
It's 1,000. Oh, okay, sorry. Miscalculated, but the answer is still correct. There it is.
Wow, that's a lot of money.
So, today to wrap up class, we're gonna talk about effective annual interest rates. Is or real rate of interest earned after adjusting the nominal rate for factors. So, as we can see, the formula for this problem is your interest rate, your effective annual interest rate equals 1 plus the interest rate over the number of times compounded raised to the number of times compounded minus 1. Does anyone have any questions? Yes.
With that, I still don't get it. It's what is the effective rate of a 12% APR loan that is compounded daily? I don't get it.
Well, let's think about it using this formula. So you have your effective annual interest rate equaling 1 plus, since you want it over a year, it's 12 divided by 365 days in a year, raised to your 365 minus 1. So from this, we get the answer 12.75%. So the effective rate of interest on your 12% loan is actually 12.75.
Oh, so you just plug it in.